Hi everyone, I'm Akin Heper from Yale NUS College, and today I'm going to talk about the long and the short of it, contest behaviors in two-thaii stalk-eyed flies. Today I'm going to be presenting some preliminary results on an observational study on these two stalk-eyed fly species. However, our results are part of a much larger research into behavioral and genomic factors that lead to the determination of winners and losers in diopsid fights. And our first species is Teleopsis thaii, there on the left. And this species is much closer to the stereotypical idea people have on diopsids. They are heavily sexually dimorphic and have these long eye stalks where the eyes can be seen at the very end as these little red dots, whereas females have much, much shorter eye stalks. Our second species, Eurydiopsis brevispinus, on the other hand, is monomorphic. So the eye stalk length is the same between both males and females. We captured our specimens mainly in two locations, in the city of Chiang Mai in the north of Thailand, in Doi International National Park, and in Queen Sigrid Botanical Park. And the captured flies were allowed to acclimate, after which they were size matched, such that the two flies participating in each fight had similar eye stalk lengths. The flies were then starved for 12 hours prior to fights and then placed in clear plastic cages where diluted honey was placed right between the flies. Each fight was recorded for about 10 minutes, after which the flies were isolated and preserved in RNA later. You can see a picture of our cages here, and the two plastic pieces below are the dividers that keep the flies apart. And you can see the red fly there right on top of the diluted honey. If we talk about our first species, Eurydiopsis brevispinus, we can see that we separated our ethogram into three main sections. Low-intensity behaviors denote no contact, while high-intensity behaviors require contact. Conflict resolution behaviors, on the other hand, denote the end of each contest. We're especially interested in outstretched forelegs and box behaviors, especially in the latter, since box has not been described in any other diopsid species. Now we can see some of these behaviors in action. We have orient towards, we have line up eye stalks, flex and extend forelegs, and then we have boxing. These two flies box for another minute and a half after this point, so we can switch to another video. We have orient towards, we have line up eye stalks, approach opponents, we have attack lunge, pursue, retreat away, and end. Now, interestingly, we see that the main differences in behavior exhibitions between the winners and losers of these fights are between pursue and retreat behaviors. This is interesting since even though we use these two behaviors to define winners and losers of each contest, losers only need to exhibit the retreat behavior one more time than the winners. However, we see that the difference here is much larger than that. Also, we see that winners tend to be more active than the losers. If we look at our flow diagrams, we see a general transition from low-intensity behaviors to high-intensity behaviors to resolution behaviors. However, we see that most of these transitions pass through outstretched forelegs and box behaviors. So a typical fight may start with orient towards, then we can see flex and extend forelegs, then approach opponents, then line up eye stalks, and then we see outstretched forelegs, box, or both behaviors. After which we see that the contest tends to end very quickly. We see a very similar story when we look at the flow diagrams for both winners and losers. We see the same transition from low intensity to high intensity to conflict resolution behaviors. And we see that pretty much every transition from low intensity behaviors to conflict resolution passes through outstretched forelegs and box. Now, this leads us to think that these two behaviors are assessment behaviors, where the winners and losers of each fight are determined, because we also see that these behaviors are almost immediately followed by pursue for winners and retreat for losers. We see similar results in our Teleopsis thaii species. Our ethogram is more or less the same. The main difference is that we no longer have box as a defined behavior, since we don't see it expressed in these species. And we have rear up as an additional behavior. Here, we're most interested in outstretched forelegs and attack lunge, since we see that these two behaviors have similar functions to outstretched forelegs and attack lunge and, to box in Eurydiopsis species. Here we have a clip of our fights. We have orient towards, we have line up eyestalks, we have attack lunge, outstretched forelegs, rear up, and then we have more attacks, and we have pursue, retreats, away, and end. When we look at how different the behavior exhibitions between winners and losers are in thaii, we see the same story with retreats and pursue behaviors, where the difference is much larger than we would expect. We also see that winners in thaii exhibit outstretched forelegs and attack lunge a lot more often than the losers do. This is consistent with our suspicion that these two behaviors determine winners and losers. When we look at our combined graph, we see the same general transition from low intensity behaviors to high intensity to resolution. And we see that almost all of the transitions from low intensity behaviors to conflict resolution pass through outstretched forelegs and attack lunge behaviors. We see a very similar story when we look at the flow diagrams, where though these are a bit more messy, we can see the transition from low intensity behaviors to high intensity to conflict resolution. And we see that almost all of these transitions pass through outstretched forelegs and attack lunge behaviors. So if we talk about our findings, we see that Eurydiopsis are much more aggressive than thaii. Though Eurydiopsis species tend to have more longer contests, up to a minute, over a minute even. Thaii only have up to 10, 20 seconds at most. We also have more contests per fight in Eurydiopsis, where one fight can have up to 12, 14 different contests, whereas thaii has 6 and maybe 8 contests per fight. We also suspect that under heavy speculation, this may point towards dimorphism in eyestalks being a result of mate choice rather than aggression, since we would have expected the opposite scenario in aggression resulting in the evolution of longer eyestalks. We find that boxing and outstretched arms may be assessment behaviors where the winners and losers are determined. And this is counter to the graded assessment theory for Diopsids, because this theory would indicate more transitions from low intensity behaviors to conflict resolution behaviors. And that is my presentation. Thank you very much for listening. And I'm free to take any questions.